What's up everyone, welcome back. Patrick here. In this next video, we're told that when the price of a box of cookies rises from $11 to $12, the quantity of muffins demanded increases by 6% and the quantity of cookies demanded decreases by 4%. And we have to find what is the cross elasticity of demand between cookies and muffins. So a little bit of information given here. Notice we're given information about cookies and muffins. So starting with cookies, we're given information about the price. We're also given information about the quantity demanded. So notice that the price goes from 11 to 12. And then we're told that the quantity demanded decreases by 4%. So we'll have negative 4% here. And then for the muffins, we're only given information about the quantity demanded. And we're told that it increases by 6% right there. Now, the cross elasticity of demand between products A and B in general is basically what? The percent change in quantity demanded of product A over the percent change in price of product B. So notice that if we're going to find the cross elasticity of demand between muffins and cookies, the numerator has to be the muffins because we're not given any information about the price for the muffins. So there's the product B can't be the muffins. Product A has to be the muffins in this case. Versus with cookies, we're given information about the price and the quantity demanded, but because we're given information about the quantity demanded for the muffins, then that means the cookies is going to be product B, and so the change in price for the cookies is what's going to go in the denominator. And so this over here, this negative 4%, we're actually not even going to use in the question. So be careful with these kinds of questions where sometimes they give you information in the question that you're not even going to use. Another trick here is that if you remember cross elasticity of demand, even though it says percent change here, usually when we're calculating this, we're calculating it as a fraction. And so what we end up having here is a decimal, the percentage in decimals. So here we have the 6%, here we have the actual price change. Here we're given the percentage, but because this here is going to end up being a fraction in the denominator, that means the numerator has to be in terms of a fraction as well. So we wouldn't put 6 in the numerator, we would actually put 0.06. So be careful with that as well. Now, if they gave us 6% here, and then over here they gave us a percentage, then we could put both of those percentages in the numerator and denominator because they would be in the same units, quote unquote. But because this here is going to be a fraction, right? We got the old price and then we got the new price. So we got new minus old, so 12 minus 11 over 12 plus 11 divided by 2 over the average price. Right? That's how we calculate that percentage change in price. Versus here, it was 6%, but again, it's got to be in the same format, so we got to put a decimal there. So just be careful with that. Okay, so from here, what we can do, I'm going to erase this. What we would end up having, if we continue this over here, is we'll end up with 0.06. Now, this is going to be a fraction over here, so I'm going to actually convert the 0.06 into a fraction, just in case the final answer is in terms of a fraction. Because on a multiple choice test, you may get different formats, and then the fraction will also convert to a decimal at the end. So the 0.06, I'm actually going to change that to 6 over 100. Over 12 minus 1 is 1. Over 12 plus 11, which is 23, divided by 2 would give us 11.5. And then over here, it's not really proper to have a decimal within a fraction, within this fraction here. So we can multiply this by 10, multiply this by 10 to move that decimal. And then 1 times 10 is just 10. So the erasing this here, we would end up with 6 over 100 divided by 10 over 115, like that. And then the 6 over 100, that actually simplifies to 3 over 50. And then the 10 over 115, that simplifies to 2 over 23, right? If we divide both sides, both the numerator, and the denominator by 5, then here we'd have 3 over 50 times 23 over 2. We would just flip that second fraction and multiply it. This would end up being 69 over 100. And then that doesn't simplify any further. So that would be the cross elasticity of demand. If you wanted it in decimals, you get 0.69. Now, if the final answer, if your prof just wants it in decimals, then this portion, you could have kept this at 0.06. You could have got the decimal here, divide them, you'd get the same thing. But again, just in case it's a multiple choice question and then a fraction format comes up, I included the fraction as well. So either of these, that's the cross elasticity of demand. Now, because it's positive, notice that these two products are substitutes. Right? When the cross elasticity of demand is positive, the two products are substitutes, and that makes sense. Cookies and muffins, they're substitutes. They're not really complements. Sometimes they're eaten together, but usually they could, for the most part, they are competitors, they're substitutes. So because that price of cookies went up, that means the quantity demanded for cookies went down, but then the quantity demanded for muffins went up. And that's why we got that positive for the cross elasticity of demand. Both of the products are substitutes.